Our last example for today will be example 3. And example 3 will touch on one of the key strategies that you will use in trigonometry. And when I write out the key strategy above, you'll be like, that kind of makes sense for trigonometry. A key strategy in trigonometry is to draw a triangle. Wow! But this will be a key strategy that we often have to use. And when we draw our triangle, we're going to want to use the definitions that we have. So we're going to want to make sure that we draw our triangle, that it includes a reference angle. What do we have in this situation? All they tell us is we have an angle in standard position with a point at -1, -4. So there's my terminal arm. This would be my angle theta in standard position. How am I going to draw my triangle? I'm going to draw my triangle by going back to the nearest x-axis and I'm going to label my reference angle. By drawing it back to the nearest x-axis, that allows me to label my reference angle. If I drew it to the y-axis, I wouldn't have a reference angle, and then I wouldn't be able to help as much with the mathematics. So once I've drawn my angle back to the nearest x-axis and have my reference angle labeled, I now know certain things about this triangle. I know this length is 1, and I know this length is 4. And one of the things you are going to get so good at in grade 12 trigonometry is doing a squared plus b squared equals c squared in your head. Mental math, without showing any work. I want you to tell me, what's the hypotenuse? The hypotenuse will be the square root of something. See if you can do it in your head. A squared plus b squared equals c squared. 1 squared is 1. 4 squared is 16. 1 plus 16 is 17. So c squared would be 17, and c would be the square root of 17. We will do this so often that you will get really good at just like a squared plus b squared equals c squared in my head. Just write down the answer for the hypotenuse or the side really quickly. And now that we've drawn that triangle, we can do sine of theta, cos of theta, and tan of theta. Because you know from grade 10 trigonometry that sine is the opposite over the hypotenuse. I look at my reference angle, my opposite side is 4, my hypotenuse is the square root of 17, but then from grade 11, I know from my cast rule that since I'm in quadrant 3, it has to be negative. So we're going to use SOHCAHTOA to write the ratio, then we're going to check our cast rule to make sure we have the sign right. Some of them will be positive, some of them will be negative. For cos is adjacent over hypotenuse. Check my cast rule. It also has to be negative. And tangent is opposite over adjacent. Check my cast rule. It has to be positive. In grade 11 maths, if you left your answer as -4 over root 17, you would lose a half a mark for not being simplified. In mathematics, having a square root in your denominator is not considered simplified. So do you remember having to rationalize your denominator? And this would be the same as -4 root 17 all over 17. In grade 12, they assume you know how to do that, and so they will no longer take off a half a mark if you don't simplify. You are allowed to leave your answer in blue as -4 over root 17. But on multiple choice questions, usually the answers are simplified. So it's not like, oh, I can forget that. No, you still need to know how to do that, but you don't have to simplify in grade 12. Same thing, if you got your answer to be 3 over 6, you could leave it as 3 over 6 instead of changing it to 1 over 2. So that's kind of nice. You don't have to simplify fractions. You don't have to rationalize denominators. You still need to know how to do that for multiple choice questions. But one of the reasons they don't get you to simplify is because we have to do so many reciprocals. And a reciprocal just flips the fraction. So if sine of theta is negative 4 over root 17, then cosecant of theta would be 17 over negative 4, root 17 over negative 4. And secant will be root 17 over negative 1. And cotangent will be 1 over 4. So we need to draw a triangle, and then if you can draw a triangle with your reference angle will tell you the ratio, because you'll be able to use an actual triangle, and then your cast rule will tell you whether it's positive or negative. All right, circle question number 8.